Greetings! Welcome to this possibly magnificently overexposed new space that I've crafted for myself. I'm quite proud of this. It will change because I like changing things. I can never settle, especially this plant here, which is a flipping elbow hazard. Never mind, mate. This is my Autodesk University class that aired last week in its entirety for your delectation and delight, minus PowerPoints, because there was none. There's no death in a sea of death pipe PowerPoints. Mine had none. You're welcome. Right, but thank you very much to everyone who did attend. It was awesome speaking to everyone in the chat afterwards. And I put out mucho notification videos leading up to this. We didn't get as many people attend who watched the notification videos, but for everyone who couldn't attend or didn't want to for reasons, then here's the video. I did plan on cutting out all the references to Autodesk University and making this a standalone bit of content in its own right, but it wouldn't have made sense. It would have been too jarring to edit out any words of Autodesk University. It just wouldn't have made sense. But for anyone who doesn't know what Autodesk University is and is just passing by and watching this, it's Autodesk's global user conference. Intel were key sponsors. They asked me to make this video on their behalf. And bear in mind, it's a sponsored class. They paid for this content piece. It's biased towards Intel, obviously, but I wouldn't have said anything in this if I didn't mean it. Intel had no direction at all on the video. They just said, can you make a video for us about our products? I said yes and cracked on. They didn't have any input. They didn't even give any edits afterwards. They didn't even come up with a title. It was all on me. They were absolute champs throughout the entire process. And that's pretty much where we're at. But you just have to bear in mind, this was not made for YouTube. It was made for a global user conference. So if it does seem a bit odd in areas and you think, oh, it doesn't conform with the normal YouTube standard protocol, well, it wasn't for YouTube. I'm just putting it online for anyone who might have missed the conference and fancies watching it. That's basically where we're at with this. So that's pretty much it. The class was called Autodesk on Intel-based laptops. Did you know it was this good? It does have a bit of a crossover with YouTube because it's filmed by a YouTuber. But there you go. It's 33 minutes long. Hope you enjoy. Well, hello all. Welcome to this Autodesk University 2021 Industry Talk. It's hosted by myself, Neil Cross, the host of the Tech3D YouTube channel, formerly called TFI, and it's done in partnership with Intel. Right, the whole point of this industry talk, this class, is to speak directly to Autodesk's customers. I want to speak directly to some of their product users who are on aging computer systems. And there's rather a lot of them out there. And how do I know this? Well, if you don't know, not too long ago, I designed from scratch, developed and then released workstation performance benchmarking tool called InvMark for Autodesk Inventor. And it grades your workstation on Inventor across various different Inventor modules, gives you a number of grades based on how your system performed, and then it uploads those scores to my online leaderboard. So after analysing my online leaderboard across a rather large sample set of uploads, it was quite apparent that a rather large amount of people are still on aging systems. In fact, around 30% of the people who uploaded to the InvMark leaderboard are on workstations and laptops from around 5 or 6 years ago or older. And that's just from the guys who had the foresight to think to themselves, I fancy testing how fast my workstation is against other people who are doing the same kind of work as me. And that kind of got me thinking, is it because they don't know that their systems are so old and so dated, or are there other reasons behind that? So that's kind of how this class formed. But of course, I do want to address this head on, and that is, of course, the world's been a very difficult place over the last couple of years. Work's been tough. It really has been for a lot of people. And migrating to a new laptop or a new desktop and spending an investment on that is not a high priority for a lot of people in tough circumstances. So, but of course, there's the guys out there who maybe did buy a laptop 5 or 6 years ago, and they still to this day think it's the best laptop that money could possibly buy. You know, it was the best back then, and it still trumps everything that could be bought today. The class is hopefully talking directly to those guys. But then, of course, there's also a rather large amount of people out there who just aren't technically minded in terms of computers. You know, they don't follow the scene. Maybe they're just not familiar with how far things have progressed and what gains and productivity boosts they could get by migrating up from an older platform. You know, the software works on their older laptop. Why do they need to migrate, you know? Well, I'm going to show you why. And I'm going to start with a little bit of a teaser, mate. Because did you know, all this time whilst I've been chatting away to you, in my top pocket here, I have a computer. Oh yeah, I do. In this rather flashy electric blue Autodesk Expert Elite branded fashionable jacket, there's a computer. And in this computer, there is more processing power for Autodesk Inventor, Fusion 360, Revit, AutoCAD, and many other Autodesk applications. That computer runs those applications faster than a Dell Precision Tower with dual Xeon processors from 7 years ago. You want to see of course you want to see the computer, mate. I think I'm telling porkies or something. No. Genuinely, that there is a computer. It's the size of a candy bar, and it will run Autodesk products faster than a desktop Dell Precision Tower from 7 years ago. That's how far things have come. That is an Intel 11th gen platformed computer from today. Do you want to see how? Well, Neil, hang on. Before, when you had that PC, yeah, I'm here. Did you call that PC before a candy bar? Yeah, well, because I'm speaking to most people in the US, so it's Autodesk University. I don't care. Candy. You're not from the US. You've never called it a candy bar in your life. Yeah, nobody in the UK calls it. It's a chocolate bar, mate. Stop trying to be all fitting in. Chocolate bar, candy bar is for you. Right, who are you? I'm the voice in your head. Who are you? Why am I stood here talking to myself? I don't know why you're talking to yourself. What are you asking me for? I said I'm the voice in your head. Ask your doctor or something. Attitude. Right, enough of the jokes. I want to talk a bit more about this. This is the chocolate bar size PC, because I truly believe that this is where our story begins with current day modern platform computing. Now, nobody is of course suggesting that you run a CAD workstation on this. It's not what it's for. It's a representation of how far things have come since 5 or 6 years ago. So this is a Dell Optiplex 7090 Ultra Form Factor computer, and it's on Intel 11th gen. And this is a PC that fits in a monitor stand, and it's relatively inexpensive. It's only about £700 or $700. And when I said that this has more power in it for Autodesk applications than Dell Workstation from around 6 or 7 years ago, that could have split the audience somewhat. Now, there'll be a subsection of people watching this who may have said, well, that's obvious, mate. You're following what's going on. I understand how things work. You're just stating the obvious. There'll be a lot of people, though, who are watching this, who will look at this and don't follow the scene. You'll just imagine that that can't be possible, right? How can that be more powerful than a huge tower workstation? But they're probably thinking to themselves, as much as I don't believe you and I can't see how that's possible, Neil, you wouldn't be saying something like that in a class like this unless there was something to it. So yeah, let's see where you're going with this. Okay, all right, let's see where I am going with this. I'm going to give you a quick demonstration. Behind me here is the very same Dell Precision workstations, the T5610 with the dual Xeon CPUs in, and I'm going to set it away running my Inmok benchmarking solution. So that's going to start running away now. And whilst it's doing that, I'm going to give you a quick demonstration of how far things have come by just casually building this Optiplex PC in the monitor stand. I'm going to then power it on. Then I'm going to run the benchmark tool that this is running, and I'm going to show you how long it takes for this to catch up to that after I've built it and then powered it on. And then that should give you a pretty good idea. Bearing in mind that that's already started, and I'm not exactly hurrying here. So we're going to put the USB-C cable in here. This is the monitor cable. All right, that's going in there. And then what we do is we turn this monitor stand around, and then we line the plastic clips up on the monitor stand, clips in, power it on, and that should fire up like so. So that's going to boot into Windows. Now what I'm going to do is a couple of quick time lapses, so we're not just stood around waiting for things to happen. Right, we're in the Windows. We're going to load up Autodesk Inventor. And that one's now on its way. So I'm just going to jump out of the way and watch how quickly this one catches up to that one. And then I'll jump back into frame. And there you go. It's already ahead, mate. We're on the third, technically the third test of 13. And in that time, between building this, powering it on, opening Inventor, starting the benchmark test, and then running it, it's caught up to that one already on the third test out of about 13. That's how far things have come. in the last 6 or 7 years. So great. That's all well and good. But like I said at the beginning, this is not a workstation. This is not a system you'd run 3D CAD on. So what I want to do in this class is give you an overview of the systems that you would. That's how powerful modern processors are with PCs that sit in your monitor stand. How good are mobile workstations? How good are other laptops? Let's take a look at those. So, at the start of this, when I said that pocket-sized PCs have got more power these days than workstations from 5 or 6 years ago, you probably weren't expecting it to be 125% faster, right? That's over twice as fast as that Tower workstation. And this PC gets all of its power through a USB-C cable, right? That's kind of where we're at here, and it fits in your monitor stand. That's crazy, right? But being the cynic that I am, I know if I was in your shoes and if I was watching this, and if I was watching me, I'd be thinking to myself, okay, you based all this, Neil, on a benchmark test, and I don't know that test. So what about it? Okay, but I'm not going to spend the entire class talking about this one test, Infomark, right? Granted, it is my test. Generally, if a workstation performs well on Inventor, it generally performs well on the majority of other Autodesk applications. And if you want to know more about Infomark, by all means, check out my channel Tech 3D, where I've explained how the test works in its entirety. But needless to say, one of the tests, for example, is a 1,000 unique part data set. That's that factory test you saw running in the background earlier on. And it goes on to then place 4 views of that on a drawing sheet. So it's a very thorough, intensive test designed to separate the good workstations from the ones that need a bit of an update. So we'll be touching a bit more back on Infomark further on in the class. But for now, let's take a closer look at what's going on under the hood in current day systems. You you'd be forgiven at this point for being a bit tired, not just now, but just in general, of hearing people tell you that everything new is always better. You know, why is everything new always better? And in this case, why are newer CPUs and newer systems that much better than older ones? Well, let's give you a quick overview on what's gone on over the last few years. So, not to put too fine a point on it, this is your average CPU. This is an Intel desktop CPU, but in many ways, the mobile CPUs are very similar. And if you take a look inside this, there we are. So inside this, there is what they call a die, and in there is billions of little transistors. And these transistors are the beating heart of the CPU. That's what makes the CPU tick, paraphrasing generations of very clever people's work there, which I'm sure they won't thank me for. But over the years, Intel have doubled the density of the transistors that are packed inside of a little die that's about the size of a thumbnail. And they've shrunk these transistors down, doubled that density, and that's what they call Moore's Law. CPUs just get faster and faster every year. And it's quite difficult to appreciate the scale of what's going on in here, but as transistors shrink, CPUs get faster and more get packed in here. Processors become faster and more efficient, and you realize that, you really do see that year on year. So just to give you a quick demonstration of the scale of what we're talking about here and what is actually inside these, let's hop on over to a good old trusty CAD demonstration, mate. We are at Autodesk University after all. I have modeled a very crude, yes, I know it looks like a wizard's hat. It's not, it's supposed to be a human hair. Yeah, I know, Inventor's not cut out for modeling biology. Inside of that, I've modeled a 1-to-1 replica of a transistor. So we jump down and zoom into that transistor. It's right the way inside there. There he is, mate. Right, that's what your average transistor kind of roughly looks like. Done very quickly. If I start to zoom out in context to the human hair, bear in mind this is one human. Look at your arm. Look at the hair on your arm if you have hairy arms. This is the size of a transistor in context to that hair. So you can now appreciate how many of those onto a surface area. The size of that. And that's led us to where we are today. More efficient, more powerful computers, both desktops and laptops. And that's taken us to the likes of this, you know, the Dell XPS, which all along has been powering this high-tech CAD demonstration where you can power a screen like this, drag your CAD application onto your laptop, unplug the screen, and off you go, right? And these laptops, these run 3D CAD now. Granted, they're not mobile workstations, sure, but these will allow you to do work on the go, a little bit of light work. Many of them are foldable convertibles as well, and they'll allow you to do sort of light work on the go. That's the kind of power you now have, which was just never possible just half a dozen years ago. So that's just one form factor of many that we have available today. If you want to get onto the current platform, let's take a look at what else is on offer. Really, mate, if you're in the market for a laptop at the moment, or if you've been shopping around for one anytime recently, there's probably one thing that's jumped up and smacked you in the chops. There's so many different brands, right? There's new brands coming out all the time, which is good for competition. It ain't great though when you're trying to decide what you want. There's so many different parts as well, and so many combinations and configurations, and how do you pick? I get it. It's difficult. But I think in our world, we can break laptops into three main categories that we're really all that interested in. I want to give you three examples of those categories as well. The first of the categories is something we've already looked at today in this video. Well, we've seen one already. It's the thin and light. And one of the best on the markets, mate, when it comes to thin and lights is this one. It's the Dell XPS 13 9310. The number of criteria needs to be satisfied for something to be classed as a thin and light. Generally, they're 13 to 14 inches in size. And obviously they've got to be thin and light, but the ethos of a thin and light is that they strive towards battery longevity, and that's really what people are looking for with thin and lights. They want it to be light, portable, have long battery, and they want to just be able to kind of open it up. They want it to start up pretty quickly, and then they just want to be able to close it and crack on, chuck it in a bag, and not really notice it. They want it to be pretty light, not get in the way. And that's kind of where this is at when it comes to that. It's very light, it's built really well. And that's something else that comes with the thin and light. They tend to be pretty good looking, right? Built very well and quite elegant devices. But with all of that, with power efficiency, with battery longevity, historically has always come a trade-off with performance. And something as thin as this, it's always been a struggle to get good performance, to get decent thermal cooling, and you've always traded off performance. Not necessarily anymore. For example, a couple of weeks ago, I reviewed the Dell Latitude 9420. I show this on the screen right now on the channel. And that is very, very similar to the XPS 13 in that it's a thin and light form factor. Comes in 13-inch or 14-inch regular or convertible. Similar to the XPS in terms of its design language, its build quality, specs are very similar to the XPS 13, but it's geared towards business users. I ran it through InvMark, just like I do with all laptops and desktops that come through the channel. And I'm not saying this for dramatic effect, but I was absolutely blown away and staggered by what I saw. Like, for example, the desktop that I used as part of my Autodesk University class back in 2018, where I was teaching people how to build the best workstation for Autodesk Inventor. The workstation I used at the time was the best that money could buy 3 years ago. It was an HP Z2 Tower G4 workstation. That one was the best you could buy. There was nothing 3 years ago at that time that you could buy that ran Inventor better. That was it. That was the pinnacle of desktop workstations 3 years ago. And this Latitude is not even marginally, it absolutely destroyed it at InvMark. And that's staggering when you think about it, because that's only 3 years old, that workstation. That's not an unreasonable production cycle, all right, for workstations. So there's people in production still using those workstations, and these thin and lights being purchased today have more power for Autodesk applications. It's not as simple as that, granted, but it's kind of crazy when you think about it that way. Still, thin and lights, they're not desktop replacements. These do not have dedicated graphics cards in them. They don't have GeForce cards or Quadro cards or RTX cards in them. They're good for sort of chucking around, right? Having lying around as if you're in a position where you can do this, having as a second laptop, for carrying around in a bag, just opening up when you're on the go, but not necessarily recommended as a main workstation or as your main computer, especially if you're a CAD user or an engineer. Right, the second category would be gaming laptops, mate. Now, with gaming laptops, that's a minefield. It really is a can of worms. There's more gaming laptops than there is anything else. All different kinds of form factors, sizes, and price points. But you could be thinking at this point, Neil, why'd you keep having imaginary conversations with yourself? And B, there was no A, but B, why are you talking about gaming laptops? This is Autodesk University. We should be talking about professional workstations and whatnot. Au contraire. You see, Autodesk have kind of thrown us a bone, really, with gaming hardware and consumer hardware, because Most of Autodesk's flagship products do: AutoCAD, Inventor, Revit, Fusion 360, Maya, Max, right? A lot of them, they work great on gaming hardware, but with a caveat. That caveat being, it's not officially supported, but it works. And that not officially supported means if you do decide to buy a gaming laptop or a gaming desktop and you want to use your Autodesk product on that hardware, well, it will run, it will work, it'll work very well. But they reserve the right to say, if you buy one of these, you're kind of on your own, but it should work. So that's the caveat. But with gaming laptops, these have come on so far recently. This one being the MSI GE Raider 76. Inside here is an Intel 11th Gen Core i9. It's got an NVIDIA RTX 3080 graphics card, 64 gigs of RAM. It's got a 360 Hz display. It's 17 inches in size. It ain't cheap. It ain't light, and it ain't small. But this thing is one of the most powerful laptops on the market. And I put it this way, this is tangibly, noticeably more powerful than the liquid-cooled desktop, 10-core desktop that I run my entire channel on. Which was one of the most powerful custom-built desktops you could put together only a year ago. It's nuts. But if you want that, you can have it. You can have it in this. And the thing about having a gaming laptop is you can do your work, and then once you're done, you can close up shop and you can play some games at the end of the day. But like I said, that certified ISV support that you get with professional hardware, you will not get with your gaming laptops. But that is one option. Your gaming laptops. Right then, and we've got the final category that defines the trifecta of laptop types that we're interested in, of course, being the mobile workstation, the staple of the CAD and engineering world. Now, back in the day, the mobile workstation really was, it only came in two types, really. You had the 15-inch and the 17-inch mobile workstation. That was about it. Nowadays, though, you've got mobile workstations coming in all different shapes and sizes. You've got thin and light mobile workstations now. But in my opinion, a mobile workstation really has a very simple set of rules to follow. And that being, it has to contain professional-grade hardware. That's it. That's it. It has to have a Xeon CPU in here. It has to have ECC RAM and a professional-grade graphics card with professional-grade driver support. That's really it. That makes it a mobile workstation in my eyes, with the same rules applied to a desktop. And this, for example, being the Dell Precision 7760, and that contains all those things. It has an 11th gen mobile Xeon in here, ECC RAM, 64 gigs, as well as the NVIDIA Quadro RTX A5000 graphics card. It's got a 4K HDR, 120 Hz display, and yeah, this is up there with one of the best mobile workstations on the market, beating out many desktop-grade workstations in the Infmark benchmark test. And this thing's spectacular. But of course, mobile workstations, I wouldn't say they come with down points, but for example, if you wanted to use this for gaming in your downtime, not so good for that. The drivers that come with mobile workstations, they're just not built for gaming, so you can't really do much in terms of gaming on this, but they're equipped for work. They come well equipped with ports, they're sturdy, they're well designed, well thought out, they come with a lot of heritage behind them. Heritage is all well and good as well, as is brand credibility and reputation, if it helps you get your work done, which it doesn't. But it's still important. Now, one of the more common questions I get asked across doing the YouTube gig that I do, it's a big question for the person asking. It's, Neil, what laptop should I get for XYZ? XYZ is normally like a CAD application of sorts with various professional workflows sort of sprinkled in the mix. And by the point of the person asking that question, they've normally done a fair bit of research by that point, and they're normally at the end of their tether because they've done their research, they've looked through various other videos, they've looked through media articles, and it's just not really helped. In fact, it's probably made things worse because those videos and articles tend to be aimed at gamers, right? And that advice doesn't really translate across to us in engineering. And it results in them being told, look, the desktop's the benchmark for performance. That's the pinnacle, right? But if you want the portability and the convenience of a laptop, which you do, well, you're going to trade off in this area if you go for that laptop. And that one there is not great at that. Oh, if you go for that laptop there, well, it's not great at this. And there's so many laptops, so many trade-offs. It's confusing. It ultimately leads to them saying, I just can't, I haven't got time to make sense of all of this. Can someone please just tell me, I use X. What should I buy, right? What's the best laptop? You can see the problem. See, the thing is, that's not actually the case anymore. It isn't. It was a long time ago. But today, if you're in the market for a mobile workstation and you've not looked at things for a long time and you're still maybe on an older platform, mobile workstations today are as powerful as desktop workstations, if not more powerful than the majority of desktop workstations. Take the one I've been showing you today, the Dell Precision 7760. Now that is a high-end mobile workstation. I'm not going to hide that fact. It is at the high end of the spectrum, but put that through InvMark with its 11th gen Xeon CPU inside it, take the equivalent desktop version of it, it is on parity with the highest of high-end Intel desktop CPUs. That's how good it is. In fact, there are very few CPUs on the market that will outperform this laptop on Autodesk Inventor. In fact, it outperforms almost every other CPU on the market from all manufacturers. It's that good. And that's Autodesk Inventor. If you use other applications, it's going to be just as good at them all. Like I said at the very start of this video, what's good for Inventor is pretty much good for all other Autodesk applications. It's ISV certified for AutoCAD, for Revit, for pretty much all of Autodesk's M&E products. And then you've got the likes of virtual reality. Maybe that's something you're thinking about doing in your business at the moment. You've not quite got around to it. Maybe the prospect of it's daunting. It's in your 5-year plan, but the justification for tens of thousands of pounds worth of hardware to implement a virtual reality system is just a bit too much for you. Or maybe that's just what you think is the cost of implementing it. It needs super heavy, massively powerful hardware to run that kind of a deal. Not necessarily the case at all, mate. Virtual reality can be run easily off of a laptop these days. That's what I'm showing you right here. These two scenes, one of them is an automotive scene, one of them is a real-world engineering VR scene. They both run off of a laptop. And that's been the case for quite some time now, but it's just getting better and better every year. Now, these two scenes, they're pretty data heavy. Neither of them have been dressed and prepped for this presentation. The automotive scene, that's actually one thing that we're seeing more and more these days, especially in the post-pandemic world. Automotive companies, instead of having customer face-to-face presentations and seminars, and they're beginning to use virtual reality now as a conduit to present their products to customers very effectively as well. But this one here, this is something that I did not so long ago. We had an exhibition in Aberdeen, and we needed to present our products to our customers in a very interactive, kind of digital way. So I came up with this virtual reality interactive scene, a sort of an underwater interactive demonstration using Autodesk VRED. So you put the headset on the customer, they walk around in VR around our product, and they would touch little orbs, and then various parts of the product would animate with them and interact. And it was almost like they were there with the product. And that was all done on a mobile workstation with a relatively inexpensive virtual reality headset. And that took minutes to set up. You know, you can port that around so easily from presentation to presentation, from booth to booth, with the minimal of hassle and aggravation. So, yeah, look, the core message that I was hoping to deliver over the duration of this class, as it's drawing to a conclusion, was, like I said right the way back at the very start, I was hoping to strike a chord with those in the Autodesk audience who are still maybe on aging systems, but they weren't yet convinced that upgrading to a newer platform would be all that worthwhile. If you remember, right back at the very start, I began this demonstration with showing how current generation systems, even slimline thin clients, were more powerful than aging workstations from 6 or 7 years ago. But that was a pretty old workstation, and the connoisseurs out there may have pointed out already that wasn't the most applicable workstation for Autodesk applications, right? You know, it's even back in its day, that probably wasn't the most suitable of workstations for Autodesk applications. But if you're still sat there thinking to yourself, I'm still not convinced, Neil. I still think my laptop's probably good enough, right? You know, you've shown me these things. I see your point, but my laptop still feels pretty snappy. So I'm still not, I'm a bit on the fence. Right, that's fine, fair enough. I'll give you a bit more information with a bit more context, courtesy of InvMark, which to my knowledge, by the way, mate, is the only benchmark in existence that tests workstation performance on Autodesk applications with an online leaderboard. So it's literally perfect for all this stuff. So here's the InvMark score for the Intel 11th Gen Dell Precision 7760. Note that it has the highest ever recorded score for large assembly build. I only noticed that when I was editing this video together. That's outstanding, mate, because what you have to bear in mind is every current generation relevant CPU, mobile and desktop platform is uploaded to InvMark. And for this to be the highest ever recorded for that, and that's not a light test, mate. It's a 3,000 part assembly constraint placement test. That's spectacular. I only noticed that when I was editing this together. Yeah, but let's say at work you have a desktop Lenovo ThinkStation P520C with a Xeon W2245 CPU. Mate, that's an 8-core workstation grade CPU released only in 2019 right there. So it's got 64 gigs of RAM. It's got a pretty decent Quadro RTX 4000. That's got to be pretty near the laptop, hasn't it? Right? Wrong. No, no, it's miles off. The laptop, the Dell Precision 11th gen laptop, is a 50% performance increase over that Lenovo from only 2019 with a workstation grade Xeon in there. Now, to be fair, even in 2019, that wasn't the right spec for Inventor. My 2018 Autodesk University class would have advised on that. Now, I don't know if the workstation was spec for other things other than that, but yeah, that's kind of where this laptop's at in comparison to what somebody might think is a very capable workstation from only 2019. Okay, so in 2018, your company bought you a Lenovo ThinkPad P52. It's got an 8th gen Core i7 with 32 gigs of RAM and a Quadro P3200. That's got to be a bit closer than the desktop, right? That sounds a little bit more capable than the desktop, right? Nope. Nope, the 11th gen system is actually measurably, it's a 73% increase over that Lenovo. And that Lenovo is no, well, I mean, that would have been no slouch back in its day, but this one just spanks it. It's just, look at that, the numbers don't lie. They're just right there. Right, here's a story that might ring true for quite a lot of people. You've got a bulk load of laptops in your business that your IT guy bought in maybe 5 or 6 years ago, right? He's got a corporate deal. He bought in a load of Dell 7510 laptops and he distributed them out to the business. And he still thinks they're the doggy's danglers, right? Even though you've tried to tell him that the 6th gen i7 is outrageously old, but he just won't have any of it. He just thinks, well, it's got 64 gigs of RAM, hasn't it, right? It's got a Quadro in, so that's all the boxes ticked, right? That's what it's got on the recommended system specs page, right? You know, it works, doesn't it? What do you mean it's slow? It's an i7. It's got to be something you're doing, right? Just do a Windows update or something, right? I'm sure we've heard all that before. Well, how about showing him that the equivalent mobile workstation from today yields a 126% increase over those mobile workstations from all that time ago. That's a passive performance increase on your engineering productivity tools. Probably won't take you long to work out how long it'll take for those to pay themselves back. And to be honest, mate, it's a similar story across the trifecta of laptop categories that I've spoke about over the course of this class. If you remember that Latitude Thin and Light I mentioned earlier on, well, bear in mind that 6th gen laptop I just spoke about there, that was the most powerful mobile workstation you could get at the time for Autodesk applications, the ones that are primarily single-threaded in nature anyway. And the 11th gen Thin and Light Latitude is 86% faster at Autodesk applications than that 6th gen Dell Precision laptop from about 6 years ago. It's where we are now. And this isn't all just synthetic fluff and numbers. This actually all applies to production work, and I've got my own personal experiences here. A friend of mine called Graham, who I've known for quite a long time, he runs his own little engineering business called GCAD, and he placed an order for a Dell Precision mobile workstation. It was the 7550 10th gen mobile workstation, and he was absolutely proud as punch to tell me all about it. Now, being the good mate that I am, the first thing I did upon hearing him tell me all about his brand new laptop was to say to him, mate, how long ago did you place the order, and do you still have time to cancel it, stop it, and order something else? Because what he'd done is he'd placed an order for a mobile workstation based on the previous generation 10th gen platform, whilst the current generation 11th gen units were actually being built and shipped. Knowing the market like I do, I know how much of a gain he would have got if he just ordered the 11th gen units at pretty much no extra cost. And Infomark actually puts the 11th gen units at a 25% performance gain over the 10th gen, again at no extra cost. So if he just cancels that order and the 11th gen one instead, he's just immediately in a better place. So Graham manages to get that order cancelled, and then he places his order for the 7760, and it's pretty much a carbon copy of the one I've been showing you today in this class. He receives it, his glorious new laptop, and genuinely, he could not be any happier. It has revolutionized, transformed, and just given his working day a complete makeover. And because he was migrating from an 8-year-old Dell Precision M6800 laptop and also a T7910 tower unit, which is about 5 years old. 2 properly aging bits of kit there. And the type of work that he does, which is 3D scanning and heavy Inventor usage, they were really starting to struggle. So we needed something new. And it, like I said, it's given his daily work a proper makeover. And you can see that from the chart that he sent in here. This huge dataset mirror that he does on a regular basis, these operations that he does, where it's sliced the times in halves and thirds. The huge step file export creation. He'd be using the laptop, like I say, for huge 3D scanning and point cloud ingest projects, something which you just never would have been able to do on his older laptop. So thanks to Graham for sharing his experiences. Thank you to Intel for sponsoring this class and providing the equipment that was made it possible to actually create this class. Thanks to you for making it through to the end. And I've tried to make this class as relevant as possible and timeless as possible. So if you do need this information moving on into the future, as time flies as it does, it should stay relevant moving on and forwards into the future. So my name is Neil Cross, and thank you again for watching this class.